You can see n is equal to 1, shell number 1. It is also called quantum number 1. Second energy level from inside is called n is equal to 2, which is also known as quantum number 2. And out here in this diagram, we have n is equal to 3. I can call it quantum number 3. And you can see electrons. Electrons are available in energy levels 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Likewise, I can go on adding electrons. Now, electrons are present in quantum numbers. And the nucleus is small, dense, small area in the middle of an atom is called nucleus. And nucleus is made up of neutrons and protons. Because nucleus is made up of neutrons and protons, they are called nucleons. Nucleons means neutrons are nucleons, protons are nucleons because they are found in the nucleus. Now this nucleons. Nucleons means neutrons plus protons. The addition of neutrons and protons are called mass number. Mass number. We have a special symbol for this. It's called capital A. And then the number of protons, we can say atomic number. Atomic number is shown using the symbol Z. When you take an element in the periodic table, for example, carbon, there are two numbers with carbon, 12, 6. The 12 means A, 6 means Z. 12 is A, 6 is Z. Z is the atomic number, A is the mass number. All right, I explained to you the meaning of mass number and atomic number, and I discussed a little bit about the structure of an atom. And in addition to this, on the left-hand side, I started the lesson by introducing to the subatomic particles present in atoms. So we see what is there in the tube. From this part, I have explained. All right, see, discuss the atomic structure. Here to explain the structure of the atoms. I explain everything. We can write an atom is made up of protons, neutrons, and electrons. Semicolon, I can write subatomic particles. Next one. Protons and neutrons. Protons and neutrons are concentrated to a highly dense area in the middle of an atom in a place called nucleus. And then electrons are arranged in quantum numbers. Electrons are arranged in quantum numbers around the nucleus. This concentration word I always get wrong. I forget to write in. Actually, I don't type it. Dense. Dense area. Copy down, please. This is roughly the arrangement of subatomic particles in a nucleus. Children, when you participate in the lesson, don't wait until the last point of the lesson, and I may ask you to copy down, because before that, you have to finish the copying down part. Don't wait till the last minute, because we can save time. Now I go to the definitions. First one, atomic number. Remember the meaning of atomic number. Okay. Atomic number. This is a number of protons. Atomic number. What is this? It is a number of protons available in the nucleus of an atom. In a neutral atom, proton number is the same as electron number. Children, we never say proton number is the electron number. We never tell that, because it's wrong. We can't say that atomic number is the electron number, because atomic number is number of protons. And also, proton number and electron number is in an atom is equal. If proton number is 6, electron number is also 6. Atomic number is given by the symbol Z and is shown in subscript. Subscript means written below in small letters on the left-hand side of the symbol. This has to go up. On the left-hand side of the symbol of an element. One simple example is oxygen. Yeah, here I write oxygen 8. And then mass number. This is the number of protons and neutrons available in the nucleus of an atom. Atomic mass is given by the symbol capital A. A is shown in superscript. You can write over here X C, A. So atomic number is here. Atomic mass is over there. Copy down that diagram. Okay. Next we go to elements. What is the meaning of elements? Elements are groups of atoms having the same atomic number. Okay. Elements have same atomic number. Certain elements are available as uniatomic form. Certain elements are available in uniatomic form. What are the examples? Maybe helium, shall we talk about the meaning of elements? Again, elements are groups of atoms having the same atomic number. Certain elements are available as uniatomic. Helium, neon, argon, they are uniatomic. In the meantime, I will read it again, I think. Elements are groups of atoms having the same atomic number. Certain elements are available as uniatomic or monoatomic, while some others are available as diatomic and polyatomic molecules. For example, nitrogen. Then we go to the next one, isotopes. Isotopes are atoms of the same element, but with different mass numbers due to different neutron numbers. We will take one or two examples for this. First example is hydrogen. Hydrogen is one example. I will take another hydrogen plus one more hydrogen like this. Okay, I go to the next one. Oxygen. Oxygen. These are atoms, different atoms. Why have I drawn 3 hydrogen atoms here? Because you will see some hydrogen having, I think I can increase this a little bit. Yeah, that's better. Isotopes are atoms of the same element, but with different mass numbers due to different neutron numbers. Hydrogen atoms are shown like this. Atomic number. And then I will write for hydrogen, I can write 1 here, 2 here, 3 here. For oxygen, I can write 6 here, 8. 8 here, 8 here. Now you try to find out the next part. Let me erase this and redraw proton number, electron number, neutron number. For these hydrogen, there are 3 hydrogen atoms. These hydrogen atoms have a single digit number 1 at the base of all the 3 atoms. And then we'll see. See, in the first one, proton number is 1. In the second one, proton number is 1. In the third one also, proton number is 1. Why? These are hydrogen isotopes. We have to show the name of the element irrespective of the isotope you are going to talk about. And for this oxygen 8 and oxygen 16, we have the mass of phosphorus 8 in 1. And here also we have 8 protons. 1 proton, 1 proton, 1 proton. For hydrogen, 8 proton and, I made a mistake here. I'll remove this. Eight here, 8 here, 16 here, 18 here. Proton number in this oxygen is 8. Proton number of oxygen with mass number 18 is also having 8 protons. In addition, electrons. Electron number is always equal to number of protons as well. So here we have 8 electrons, 8 electrons. And then we got neutrons. If there are two numbers here, number 1 up there, number 1 down here. The lower one is a proton. Upper value is proton plus neutron. Therefore, we can find out the neutron number if you remove the atomic number from the mass number. Here, 0 neutrons are there. Here, neutrons 1. Here, neutrons 2. For oxygen, neutron number 8. Here, neutron number 10. Those are the differences. Okay. Shall we complete this table number 3? Please do it yourself. Shall we see whether you have got the answers correctly? Particle. If you want, you can write the name also. Here. Protons. Neutrons. Electrons. Relative atomic mass of proton is 1 atomic mass unit. Neutrons, 1 atomic mass unit. Electrons, 1 over 1836 AMU. Relative charge of proton is +1, +1. Neutrons, 0. Electrons, -1. One student entered now with the name Taranga Isrumali or Isrumali. Did you come from my last class? There was one child, I couldn't find out that girl here. Is this your first class or you came to Mahabagi first class last time? And is this your name? If this is your parents' name, can I know your name, please? Hello, you can write in the chat if you don't want to talk. This Taranga is Rumali. What's your name, do? Is it your name or your parents' name? I don't know whether you have received the copy of the tutor as well. All right. Now, these are the properties of subatomic particles. The mass of these particles and their charges. I'm teaching this in a very, very relaxed mode because these are all O-level stuff. I'm just trying to recap. Go to the part D. Properties of subatomic particles that are shown in the table above, that means charges and masses, can be demonstrated by allowing subatomic particles to pass through two plates which are electrically charged. Sketch a diagram to show the above experiment and discuss. Actually, to do this work, I explained this to you last week, and if there's a child who was absent last week, this is a diagram I explained. You can take a metal plate. You can take a metal plate. Actually, you can't, I mean, you and I, we can't do this in the laboratory. There are special apparatus which are to be used, and we can't do it in our laboratory. We don't have the facilities. Let's say this metal plate is positively charged, and the second metal plate is negatively charged. They are part of an electric field. If you allow a neutron beam, neutrons are negatively charged or positively charged. Neutrons have no charge. If you allow a neutron to go through this, it will go directly up. Just straight up. This is a beam of neutron. In the meantime, if you allow, I did this lesson, this part in the last week lesson. So the children who came for the last class